Okay, so formally, direct variation is a linear relationship between two variables that can be written in the form y equals k times x, or k equals y divided by x, where x is not equal to 0. Now, from what I just described, that probably seems like it's odd, because why does that fit into what we've been talking about? Well, notice the very first thing they tell you about direct variation is it's linear. So that means when we graph it, it's the graph of a line. Well, that's exactly why it fits in chapter 5, because think of what this whole chapter has been about. This whole chapter has been about graphing lines. So here, this is just another way to talk about a line we're going to graph. The constant of variation, that's the fixed number k in a direct variation equation. That's going to be that relationship that we see developing between the numbers. If there's one worker to build 2 computers and 2 workers to build 4 computers, it might be a half. All right, because for every 1 worker, there's 2 computers getting built. Whatever that relationship shows is going to be the constant of variation, how much it's changing by. So as we go on to look at the first example here, it's asking me to tell whether each equation represents direct variation, and if so, identify the constant of variation. Now they just gave us a formula for direct variation. It's supposed to say y equals k times x. Now if you remember, I've told you already in this chapter that x and y, no matter what form of the equation we look at, are always going to say x and y. So the only thing that in that little equation there that's going to end up changing into a number is that k. K is going to represent that constant of variation there. So here's what you got to know. This is really the same thing as slope-intercept form that we talked about last week. The only thing that's curious about this, or odd, is that this b value here is always going to have to equal 0 to make it look like this. Because if it says plus 2 or plus 9 or plus 7 at the end, all right, there's going to be more than what this general form shows us for direct variation. So you want to set everything up to make it look like slope-intercept form, but the b value has to equal 0. So I've got y equals mx plus b form here. All right, so if I'm looking at what they give us in A, y plus 8 equals x, I'm going to go ahead and shift 8 over to the other side, because again, that left side just has to say y equals. All right, well, if I do that, I'm going to do that just like I'm solving an equation. So you can see that's why they're subtracting 8 from both sides. And when I do that, it says y equals x minus 8. Now that is slope-intercept form, but as you can see there, at the end, the b number says minus 8 or negative 8, not 0. Again, it has to be 0 to be direct variation here. So when they're asking me, is this direct variation, the answer is no, simply because there's something there at the end. All right, this minus 8 is the problem. It's got to be a 0. So then we go on here, we look at this one. 3y equals 2x. Again, I want to get this in slope-intercept form, but I want the b value here to be 0. So 3y equals 2x. Got to send 3 over because y has got to be by itself. So I'm going to go ahead and chop 3 out all the way across here. Again, I'm doing this just like I'm solving an equation, but nothing really ever seriously combines. So if this is multiplication, doing the opposite, which is dividing, which is why they're dividing by 3. So I've got y equals 2/3 x. Well, remember, direct variation is y equals a number times x. Well, that's exactly what this is, a number times x. If we want to talk about it in slope-intercept form, it would be like there's a 0 here at the end. Well, there's no number here at the end, so that's indeed a 0. All right, if you want me to add plus 0, I can. You know that's the same thing. Adding 0 to something always gives me exactly what I had. 3 plus 0 is always 3. 7 plus 0 is always 7. X plus 0 is always x. All right, so since that's in form, all right, that means yes, this is a direct variation, a number times x. What's the constant of variation? Well, there's only one number in the question, so it's got to be this 2/3. What does the constant of variation mean? Well, we don't have any real meaning in this question, but we can make it mean whatever we think it wants to mean. So if we want to say every 2 people at the party are going to eat a total of 3 slices of pizza, then that's what it means. So if I have 4 people at the party, since that constant's got a hole, that means 4 people are going to eat 6 slices of pizza. If I have 6 people at the party, they're going to eat 9 slices of pizza. And on down the list we go. All right, so let's look at this next one here. Tell whether each set of data represents direct variation. If so, identify the constant of variation and write the direct variation equation. So they gave us in the definitions, this will be nothing new, a way to find just the constant of variation. They said that the constant of variation, k, is equal to y divided by x. So what we want to do here is take our y values and divide them by our x values and find our constant of variation, if there's even a constant variation. Now, one thing that's a little bit different about this question, you'll see some questions like this in the homework, some that are the opposite way. There's no x, there's no y. You're just going to label them x and y. So I'm going to label the top one x, the bottom one y. That's always the way I'm going to do it. X is first, then y. It's the same way we do graphing. All right, so if there's no value there, and it may not say x, it may not say y, fill them in, make them exist. Put x in, put y in. All right, so the constant of variation says take my y values and divide them by my x values. So I'm going to do 2 divided by 69 and get a result. 3 divided by 99 and get a result. 4 divided by 129 and get a result, which is what they're showing you down here. Now, as you can see, with 3 over 99, that's equal to 1 over 33. But these other two guys, 2 over 69 and 4 over 129, those are not equal to 1 over 33. Since those are not equal to 1 over 33, there's no constant of variation here. All right? If there's no constant of variation, it's not direct variation. So here, it's not direct variation, end of discussion. If the fraction there would have all reduced to 1 over 33, then all of a sudden, yes, this would turn into direct variation. And then when they would ask you what would be the constant of variation, well, if they all reduce to 1 over 33, you've only got one number to work with, 1 over 33. So the constant would then be 1 over 33. Then when they have you write the equation, go back to what we just did. Y equals a number times x. The number is 1 over 33. So y equals 1/33 x. All right, number 3. Tell whether the graph represents direct variation. If so, identify the constant of variation and then write the direct variation equation. So again, that equation is going to look like slope-intercept form, but the b value here has to equal 0. So just looking at this graph, you should be able to tell me right away if this is direct variation or not. If the b value is 0 in slope-intercept form, that means that the graph has to go through 0 on the y-axis to make this work. Well, look at the graph. It goes through 0 on the y-axis. Since it goes through 0 on the y-axis here, this one is automatically a yes. This is direct variation. Now, let's talk about now the constant of variation and the equation here. All right, I've got this y equals mx plus b form, but b is going to equal 0. Well, look, to write this equation, the only other thing I need is slope. So slope must be the same thing as my constant of variation. But that's a good thing, because we know how to find slope looking at a chart. Slope is the rise and the run when we look at a chart. How much it changes up and down, and how much it changes moving to the right. So if I look at this graph, going from this point to this point, find the rise, find the run. How much I'm going to move up and down, and then how much I'm moving to the right. Well, to go from this point to this point, I'm making 2 jumps down. So the rise is -2. The run is how much I'm moving to the right. So here I'm making 1, 2, 3, 4 jumps to the right. So my run is 4. All right, so that makes my slope -2 over 4, or we can reduce that down to -1/2. Well, that's my slope. So change m into my slope in my equation, and we got it. Constant of variation is -1/2. Equation is y equals -1/2 x. All right, let's take a look at number 4. Truck travels at a speed of 55 miles an hour. Write a direct variation equation for the distance y the truck travels in x hours. Use the formula d equals rt, where d is distance, r is rate, and t is time. So, the one number we have here is the rate, 55 miles an hour. How do I know it's the rate? Because it says miles per hour. Miles per hour is a rate, so it's only logical that that 55 has to be the rate in the formula. D and T, I don't know. But if we look back at what it says the distance y the truck travels, so distance is going to change into y, which is where you see that arrow there pointing towards the D. All right? And x hours, which is why you see the arrow pointing at t, showing I'm going to change it to x. R changes into 55 because that's the only number we have. So y equals 55x. That's the equation I'm going to work with here. Now, if we're talking about direct variation, and we are, we know that the graph has to go through 0, 0. It makes sense. If I say I've spent no time on the road, how many miles have I covered? None, of course. Right? That's what direct variation shows. If I haven't spent any time on the road in this case, no miles could be traveled. So the graph is going to have to go through 0, 0. We're going to have to sketch the rest of it. So that's what they're going to show us here on the next slide, is me figuring this out. Now, they throw out the negatives because negatives don't make sense. This isn't a Back to the Future situation, so there's no negative time, there's no negative distances here. Even if I put the car in reverse, I'm still clocking a positive amount of distance. All right, so they threw out the negatives. They're only giving me quadrant 1 to graph in here. All right, so they plot some points using the table method. So they said at 3 hours in, how many miles have we traveled? Well, if we're going 55 miles an hour, that's going to show me having covered 165 miles. At 6 hours in, how much distance have I covered? Well, 55 miles an hour, I've covered 330 miles. So I've got 3,165 and 6,330, which I'm then going to come over here and graph on my number line. Again, the first one, I didn't have to figure out. If I've spent no time on the road, I've covered no distance. That's a sure thing. That's why the first one says 0, 0. So I'm going to plot these 3 points and connect them, showing the distance the truck has traveled at any point in time along the line. All right, so now let's go answer what the question was actually going to seek out for me to find here. The question wants to know, how long does it take the truck to travel 660 miles? Well, if I want to find how long it's going to take, that means I'm finding x. If I'm finding x, that means I have y. So I'm going to change y into 660 and solve the equation. So I'm saying, what number am I multiplying by 55 to get to 660? Well, that's a multiplication equation, a simple one-step multiplication equation no less. So you can solve that by dividing. So I'm going to divide across by 55. 660 divided by 55 is 12. So it's going to take the truck 12 hours to travel 660 miles. You don't want to plug 660 in for x. Remember, x represents the distance here, or the time rather. 660 miles is not the time. All right, that's the distance. All right, so I got to plug that in for distance, which is what we changed y into. All right, if you change x into 660, you're really answering the question, if the truck is on the road for 660 hours, how many miles am I going to travel? I'm probably going around the earth. All right, that's going to be a long trip. All right, you don't want to do that. All right, you're finding the value of x when y is changed into 660. All right, so let's take a look at the concluding examples here. Number 1, we're supposed to tell whether the equation 3y plus 4x equals 0 is direct variation, and if so, identify the constant of variation. So again, we want to get this in slope-intercept form, y equals mx plus b form, but b is supposed to equal 0. If it equals 0, it's direct variation. If it's not, it's something else. We don't care what the something else is because that's not what they're asking me to do. So if I've got 3y plus 4x equals 0, the only thing that's supposed to be on this left side here is y. So that means 3 has got to get thrown over, 4x has got to get thrown over to the other side. Again, you do that just like you're solving an equation here. All All right, but you never really combine anything. You're using that opposite side to the opposite rule over and over and over again. So start off, as you can see, they're throwing the 4x over to the other side first. Subtracting 4x from both sides gives me 3y equals negative 4x plus 0. Now, this isn't bad, but I still got to get rid of the 3, because remember, it's only supposed to be y. So now I'm going to move the 3. Again, I'm going to do that just like I'm solving an equation here. It's multiplied right now, so I'm going to solve that by dividing across by 3. Now, with this 0 here, this doesn't mean anything. But if you want to keep the plus 0 there and show you're dividing it by 3, you can. It gives me y, negative 4/3 x, and 0 divided by 3 is 0. Is that direct variation? Well, since this number here at the end is 0, yes, this is direct variation. Right? The question then is, what's the constant of variation? Well, again, it's the only number you have left in the problem, negative 4/3. So the constant of variation is negative 4/3. Number 2, tell whether the set of data represents direct variation. If so, identify the constant of variation and then write the direct variation equation. So remember, they gave us that other formula here to work with. Constant of variation is equal to y divided by x. So you want to take your y values and divide them by your x values. Now again, as we saw in the question earlier, if they're not labeled, you just force the labels on them. Throw x on the top and y on the bottom, or x on the left and y on the right if it's a column that goes up down. All right, so as you can see, they're taking the y values and dividing them by the x values here. 5 divided by 3750, 9 divided by 67.5, 14 divided by 105. Well, as you can see, each one of those returns a value of 0.13 with the 3 repeating. Since the number is the same all the time, that implies that there is a constant of variation, which is 0.13 repeating. So yes, this is direct variation. Write the equation now. Again, it's this same equation we've been working with, slope-intercept, m is going to equal your constant of variation. Now, if you come down here, you might notice that I wrote 2/15. I wrote 2/15 because 2/15 is 0.13 with 3 repeating, written as a fraction. So here, I wrote 2/15 x. If you want to write 2/15 x plus 0 to make yourself feel good, you can, but that's your final equation.